Welcome back, guys. In this video I'm going to be talking about empirical formulas and how to know if a compound is ionic or molecular. Let's get started. The first example I have here with me is we are asked to find the empirical formula of these compounds. We have the first one to be C2N2, the second one to be B2H6, the third one to be C6H6, this one to be C9H20, and the last one so we have to find the empirical formula of all these compounds. So the first thing you have to do is you just have to have it in mind, have this in mind that you have to cancel here. Like, can 2 go into? Yes, 2 can go into. So 2 goes into one time, 2 goes into one time. So the output of this will be Cn. The next one, can 2 go in 6? Yes. You look for the smallest value, smallest number here. Our smallest number is 2. So you check, will 2 go in 6? Yes, 2 can go in 6. So you use the smallest one. We can also use 1. You have to always start from 1. If we use 1 here, can 1 go in with 2? 1 can go in anything. Like 1 can go in 2 can go in 6, can go in 10, can go in any number you used. But we always start from 2. So here, can 2 go in 2? Yes, it can go into one time. Can 2 go in 6? Yes. 3. So what do we have here? We have BH3. Then the next one, we have C6H6. We know 2 can go in this, 2 can go in both. 2 can go in 6, 2 can go in 6. But we always make sure we use the value that will go in it, like cutting it into smallest value. We have to use the one that the value that we use that will make it to be in the smallest value. Then here we can use 2. 2 can go in this, but if we use 2 here, 2 will go in 6 3 times. 2 will go in 6 again 3 times. That will be C3H3. So we will still have to use 3 again. So here we can say 6 here 1, 6 can go here to 1. So that will be CH. Here we have 920. Can 2 go in 9? No. Can 2 go in this? Yes. But we cannot use 2 because it has to, the values we'll be using has to go in both. We must be able to use it in both, not only one. So it can go in 20, but it can't go in 9. Can 3 go in 9? Yes. Can 3 go in 20? No, it can't. So we can't use that. So you compare it. So after comparing it, we use 4. 4 cannot work here as well because 4 cannot go in 9, but it can go in 20. But when we try 9, 9 can go in 9, but we can't use 9 for 20. It's wrong. 20 cannot go in 9. That one can never be possible, but it can go in 20. So this, like this one here, we just leave it like that. C9H20. You just have to make sure the number you'll be using will be just make sure the number you'll be using will always go with both. You can't just say because 2 can go in 20, so I have to ignore 9. No, it's not possible. That's not how empirical formulas works. So you have to use the number that will go in both. Then the last one here, we have P4, we have phosphorus and oxygen. So can 2 go in 4? Yes. 2 can also go here. So 2 can go in 4 2 times here 5 times. Alright, P2 5. 0.05. So this is what we have here. Check again. Can 2 go here? Yes. Can 2 go here? No. Can 5 go here? No. Can 5 go here? Yes. So we just have to leave it like this. We always like here we have an odd number, we have an even number. If you have odd and even number, you know that it can never work, because we have odd and even number. It's only if we have even and even, that's when it will work. So that's all about empirical formula. So the next one we'll be talking about is ionic and molecular, how to recognize them.